Good evening, everybody. My name is Seth. I work here in SBCU. Thank you guys so much for joining us. We have a lot of people in the crowd tonight. All you guys here taking SBCU classes. I hope they're going amazing. There's also some local riders visiting us tonight. Thank you for coming down to Morgan Hill. And then all of you guys joining us online, thank you. How many of you know the difference of when you went from down tube shifters to a bike with STI shifting? It was massive, right? The amount of control that you had at your fingertips, you could never go back from that, right? What about a rigid mountain bike and then one with modern suspension? My goodness, the amount of, the increase in performance, control, and speed, you couldn't pay me to go back. Those two jumps, those two big leaps of innovation, I want you to know, are the exact same with the new Ruby and Roubaix for endurance road bikes. It completely changes what you can do on a bike, and we're constantly chasing after what perfection is when you're on your bike. And really that brings us to what our founding principle is, what Specialized was founded on, and that's to focus on the rider's need for technically advanced products that provide a performance benefit. So you better believe that as we were building these bikes, we were working with our professional athletes. We were designing a bike that would best prepare Tom Boonen to win in the Paris-Roubaix this year. Maybe if not him, some other young Slovakian, who knows. But also, more than just professional athletes, this applies to you and I. It's us going out, riding our bikes, wanting to go out longer, wanting to just have more fun, and not just designing it for the cobbles in Europe, but for roads that we find ourselves on all the time when we're out on our bikes. It's easy to believe that smoother is faster, because we know that on a long ride, if our hands go numb, we're not going to be as fast. Or if we've just had our body beaten up, it's going to be harder to beat our buddies to that next county line sprint. In designing these bikes, we learned beyond a shadow of a doubt that there isn't anything faster and there isn't anything smoother. There's a lot of work that got into us making such a bold statement. And to tell you about the work, to tell you about the development process, the partnership, and everything that led up to these two bikes being here for you guys to ride, are Chris Yu, who leads Integrated Technologies here at Specialized, and John Cordoba, our road product manager, who's seen these bikes for their entire lifespan so far. Thank you guys for joining us.
Thanks, Seth.
Thank you.
Thanks. Thanks for coming in, and thanks to everyone again for tuning in. By now, I think many of you have probably heard about our long history of innovation and collaboration with McLaren. And for those of you who haven't heard about McLaren, they're a company with a history rooted in Formula One, and they really are world leaders in bringing technology and data and applying that towards making product and specifically vehicles perform better. And so we've worked with them in the past on things like aerodynamics and carbon composites. But if you think about it, McLaren being rooted in Formula One, they're really, really good at suspension and using suspension to make vehicles perform better. So at the beginning of the project on the Ruby and Roubaix, it made a lot of sense for us to partner with them on that as well. And so working with McLaren, we're able to do a couple of really, really neat things. One of those things is using their expertise in data acquisition and using their advanced labs, we're able to go out and measure the types of roads that we just saw Seth point out earlier and be able to replay those conditions in a controlled environment. And that allows us to take our prototypes and be able to isolate them and really quantify whether or not they're performing as we expect them to. But maybe more advanced and even more useful than that is they have a great capability of turning all of this into a virtual world, into a simulation. And that's powerful because instead of doing maybe just 10 prototypes, we're able to do thousands in the same amount of time. And not only that, we're able to do things that maybe aren't even possible today, but give us a direction in where we need to head in order to get that performance out of the product. And so combined with all this work and expertise on the McLaren side, with a long history of engineering expertise and the ability to create bikes like the original Roubaix, guys like Chris DeLuzio, Tyler Kraus, and Luke Callahan, that expertise combined into some initial prototypes where they're funky looking, and in many cases, they worked really well when it came to smoothness or sometimes speed. but they all had some kind of deficiency, and that's really where the bike expertise and the ride experience comes in. Whether it's funky handling or power transfer, there's something weird about each one of these different prototypes. But not all was lost. Out of this process of working with McLaren and developing some of these prototypes, we came to really the understanding, the key fundamental understanding, that not all compliance is created equal. And more importantly, we're able to kind of categorize compliance into two major bins, being splay, what we call splay, and axial. So let's dive a little bit into what that really means. Splay is something that basically every road bike in the history of bikes has used when it comes to trying to build in compliance. And what that means is when you hit something, the fork blades usually, or the steer, is bending. And by bending, you feel less of a hit. Makes sense, right? You go and hit something, if all the stuff under you is bending, then you'll feel less of a jolt. But the downside is because of that bending, you're getting slowed down. And so when you're flexing the blades, when you're hitting something, they'll flex back, and that back is pushing you, and you're slowing down. And so even though it's smoother, it's not necessarily faster. That's not what we want. On the other side, we have what's called axial compliance, and that's simply anything that moves in line with the fork blades. This is something that we all know, we've all seen in mountain bikes specifically, and in mountain bikes, we see that axial compliance introduced at the fork, between the frame and the wheel. And in most of those cases, we've all probably experienced it. It works really well, right? It's smooth that you can hit some really big bumps, and it feels pretty smooth. But for a road race application, there's some downsides. So for a road race bike like a Ruby and Roubaix, we expect it to be really solid in power transfer, and we expect it to be able to carve into corners really tightly and precisely. And for those of us that have ridden mountain bikes, in those applications, there's sometimes some disadvantages. So you'll get bobbing, some power loss, and when it comes time to carve that corner, it may not be as precise as a road race platform. And so given the pros and cons of these different setups, we came to the aha moment. And that is, we need to suspend the rider and not the bike. Sounds subtle, sounds simple, but it's key. And in order to implement this, what we did was we simply moved the axial compliance from where we see it in mountain bikes between the wheel and the head tube to above the head tube. And so by doing that, we keep most of the benefits, essentially all the benefits in terms of compliance and smoothness out of an axial unit, but we remove essentially all of the disadvantages for a road race application. There's an uninterrupted force path between the front wheel, through the fork, into the frame, to the rear wheel. So when it comes time to carve that corner or get up and go, you feel like you're on a road race platform, but when you hit those bumps, you still get that compliance advantage. And so this is our cartoon photo. The feature that brings this all to life is the new Future Shock in the Ruby and Roubaix.
Yeah, thanks, Chris, for that. So thank all of you for being here and taking time to join us here to talk about a little about the Ruby and Roubaix. I want to talk to you guys a little bit about the Future Shock. So with all of our experience that we have with suspension mountain bikes, it could have been pretty easily to just go ahead and put something with hydraulic fluid on there and with seals. But I want to show you why this piece of technology is so important on the way that we built it. Right? So we see here the Future Shock actually moving freely. We actually have 20 millimeters of uninterrupted movement that's hypersensitive. What does it mean when it's hypersensitive? It means that all those little vibrations, all that road that had a chip seal, is going to absorb all of that really easily. We don't want to put any hydraulic fluid in there or any seals because it's going to take a lot of force to open up that seal and push through it, as you may see on your mountain bike. So we have 20 millimeters of travel. It's always active. We want to make sure that it's always active. We don't want to lock it out or anything like that because we want to make sure that it takes up all those little chip seals on the road. And something that's pretty unique, it's also adjustable. You can adjust it depending on your riding style and on the conditions of road that you're riding. So it's very important that, based on the study with McLaren, we found a set of needs for the front end. Well, for the rear end, we have a different set of needs. We actually tested something similar to the Future Shock on the rear, where it went an axial movement, went up and down, but it doesn't really work the way that we need it to work.
because it changes a lot of your pedaling angle. And those of you that are here at SBCU classes for body geometry fit, understand that we don't want to change the pedaling angle as you're pedaling through the bike. So we have a different set of movement here in the back. So in the back, the actual seat post and saddle move in an arc, making sure that your angle on your knee stays the same throughout the whole travel. How do we accomplish this? So we accomplish this by a few things. Learning with the tarmac by dropping the seat clamp a little bit gives us more seat post exposed, that giving us more movement at the seat post. We went a little bit more on this bike. We dropped the clamp down 65 millimeters to give us more seat post exposed. We also dropped the seat stays to make sure it allows for the seat post to move further back. And we have the CGR seat post. All of this gives us that nice arc that we wanted to get according to the McLaren simulation. So 4,500%, over 4,500. Do you want to explain to us what that means?
That is a crazy number. What is that? And so with all the features that John just showed on the new Ruby and Roubaix, you would expect there should be a performance benefit, right? And so going back to our partners at McLaren, they have expertise in not only designing and kind of building in the data into the product, but also being able to quantify what that benefit is. And so over 4,500% turns out to be the amount of improvement in front-end smoothness of the new Ruby and Roubaix over the previous SL4 bike. Now, it's a huge number, and even compared to some of the more recent competitors with some interesting features, it's still over a 10x factor improvement in smoothness over that. The other thing that we see on here is there's a significant benefit in rear-end compliance as well. But one of the things that jumps out is like, well, 4,000+% and 19% in the back. Why didn't you do 4,000% in the rear as well, right? And so it turns out this is an engineered decision. Through a lot of field testing and also simulation with McLaren, we found that, yeah, we can put an extraordinary amount of compliance in the rear, but we start to get into not only feedback that it starts to become feeling unbalanced, but a lot of the disadvantages that John pointed out earlier in terms of pedal bobbing and changing of saddle height, those all became much, much more apparent. And so through that process of using data as well as field testing through different prototypes, we arrived at this combination as appropriate balance between front and rear compliance. The other thing that I want to throw out there is we see three different numbers that are really, really large, nearly 4,000% or over in some cases. Those represent the three different springs that come with the Ruby and Roubaix and are able to be tuned by the rider. And so naturally, the question is, how do we choose that spring? And we have a pretty cool little chart to be able to do that.
Yes, thanks, Chris. We have here a chart that it's on our website, and you can choose the spring rate depending on your riding style or the conditions of the roads. Now, this is just a suggestion. What I do recommend for all of you to do is to go out and ride a loop, go home, change the spring, and then go out and ride the same loop again and see which one's best for you. I can say that personally, I like the softest spring. That's just what I prefer. I know Chris has maybe a different preference, so go out and test it out, see which one you like. So we can't talk about road bike here at Specialized without talking about performance, right? It's in our DNA. We all love to make sure that the road bike performs at its highest level. So some of the features that make the Ruby and Roubaix perform really well are, one of them, rider first engineering. How many of you have written the new tarmac? Okay, quite a few hands. And what do you think about the rider first engineering? Yeah? All right, cool. So we all love it, right? So we knew that we wanted to continue with that, and we wanted to bring this over into the Roubaix. So we make sure that every single frame size is specific for the rider's needs for each different height. We also made sure that we have the lightest weight possible on this bike. So we have the lightest frame that we've ever built on a road platform. We knew that adding some of these features were going to give us a little bit of weight, and we were okay with that, knowing that we were going to drop weight out of the frame. We also improved the aerodynamics. This frame and fork are actually more aerodynamic than the previous SL4. We know that we're out there in the wind, and we want to make sure we go as fast as possible. Well, I know I worked at a bike shop, and one of the greatest benefits of the Roubaix is the wide fit range. Riders love the fact that maybe they don't have to run as many spacers underneath their stem, or they don't have to run a happy stem. So we wanted to make sure that we build up upon that. So with that, we actually created the hover bar. The hover bar gets us 5 millimeters taller on the highest setting than the previous SL4. Well, and for those riders that maybe don't need the spacers or need the stack, they can take off the hover bar and actually gets you 5 millimeters lower than the previous SL4.
This is a cool experiment. So this experiment, which I'll explain in a second, came out of a question that I think a lot of you probably are having right now, and originated really when we went to field test these bikes with our pro athletes. And that question was, with a future shock system that's always active, when it comes time for me to get up and sprint or climb out of the saddle and it's moving a little bit, am I losing anything from an efficiency standpoint? It's a great question, and so in order to answer it rigorously, we enlisted the help of our friends at the University of Colorado Boulder. And this is their locomotion lab, which is a controlled environment where we can measure the metabolic efficiency of riders. And so we did a study over 10 different subjects where we compared a standard production Ruby and Roubaix with a future shock and a prototype where we effectively just locked it out so it's fully rigid. And in this study, on a treadmill incline, so you have to be going the same power to stay on there, we're measuring differences in oxygen consumption among the riders. And what the lab found was across all the riders, there was effectively no difference in metabolic efficiency between the two setups. And so really the takeaway is when it comes time to get up and go and sprint or climb, there's really no performance disadvantage associated with all the other benefits of the future shock. When speaking about performance, confidence is actually one of those things too, right? So if we feel more confident in the bike, we can rail corners harder, as one example. And railing corners harder really comes down to what we feel and know as traction. And so traction is something that we all experience, the more the better. But of course, again, working with our friends at McLaren, it's something that we're able to quantify and put numbers to. And so the way we did that was, if you think about traction as effectively how long or how often your front tire is stuck to the ground, the longer that happens, the more traction and more control you'll have. And so by applying that metric and running through the new future shock system through McLaren's system, we're able to actually put a number to that benefit. And so there is a significant increase in this traction metric compared to the previous SL4 bike. But it's not all about numbers, right? It's about how we feel on the road. And this is something that, despite any of the numbers up here, is something that is one of the first things that most riders comment on the bike.
Yeah, well, it's pretty funny to bring that up because how we got to this question was throughout the field testing process. We were all out riding our bikes, our field test bikes, and we're all here at Specialized Strava geeks, or at least most of us are, and we would come back, upload our ride, and see automatically PRs on all the descents that we've been doing for the last 5 to 10 years. Like, I didn't change anything other than the bike. I didn't feel like I went any faster, but we got PRs on the downhills, and we're like, okay, well, something's up here.
It's kind of funny because we started noticing who was taking out a field test bike just by getting the notifications on the downhill KLM. Yeah. So it's pretty cool.
So, and to add confidence, it's disc brakes. I mean, we've seen it for the last couple weeks in Pro Tour racing. They're winning on disc brake bikes. They're getting more confidence. How many of you would go and ride a mountain bike with cantilever brakes? I didn't think I would see a single hand up. That's right. So. It's still on one? How often do you ride it?
Not very often. It was a wild comparison test. I took that and a modern one back to back, same trails, even climbed faster on a full suspension.
Yeah. So
it was amazing.
Yeah. So same here with disc brakes on road bikes. It just gives you more confidence. You're able to brake later into the corners. You're able to have more modulation. You're able to brake in wet weather. So why wouldn't you? We also have through axle front and rear. This gives us a ton of stiffness on the frame when we're sprinting, when we're cornering. Well, how else gives us more confidence? Being able to put wider tires. We all know that a wider tire is going to have more traction. We've seen pro riders adapt to now to wider tires. We've seen them asking for wider tires. We know that by running a wider tire, we're actually not losing any more watts than we would with a narrower tire. So there's tons of benefits right there. Well, with that, I want to bring over Seth. Thank you all.
Guys, thank you so much for talking us through that again.
Thanks.
Thank you. So at this point, I hope you guys are super excited about these bikes if you weren't already. But this is when I want to open it up for questions from our audience here, as well as our audience online. I have my phone out, so anything you guys are, any comments or questions you guys are asking, I can easily see right here, and we'll be answering as many as we possibly can. So for those of you here in the audience, if you guys would come on up, we'll be taking questions from this microphone right here. You can direct it at these guys. So while you guys are thinking of questions and coming on up here, let me just take a couple from online already. And the first one, it's not really a question, but I'm going to answer it. It's from James. He says, I love Specialized, but I cannot ride this wonky tech. James, that's not really a question, but I just wanted to address it. I was really critical of this when I first saw it around the office, and I said some rude things to John and a couple of the other guys on the road team about it. And I had my mind completely blown when I went out and rode this bike. Just like John said, like what you can do on it, how you can descend, how like much performance you have, but also still how comfortable it is. It's amazing, and really, this technology is here to stay. And once you ride it, you'll definitely believe in it. So that's what I'd ask you to do, James. Some more questions come online. Jesse asks, when can I see pros riding these bikes?
Great question, Jesse. So as you would imagine with a name like Roubaix, that its centerpiece race is at Paris-Roubaix coming up this spring. But like any other major new products that we're introducing, you may see some of our riders testing it in some events leading up to that.
Cool. Thanks.
Hey guys, my name is Mark. I was just curious, what is the recommended service interval for the Future Shock on the front?
Oh, great question, Mark. So the Future Shock is completely sealed, and there's nothing that's going to go inside, or nothing that's going to come out. So the recommended time is 500 hours, and that's just mainly just needing to be re-greased. At that time, you would send it to a service center, and it will get all re-greased again.
And just for James, I rode one today at the lunch ride, and it was amazing.
Nice.
Cool. Thanks, Mark.
Thanks, Mark. All right, guys, I have another one for you. Legacy Bicycles, this is a shop down in Australia. They're tuning in. It's actually the future for them. It's Thursday afternoon. What kind of feedback are you getting from dealers who have been selling these bikes? And is the Future Shock transferable to other road bikes?
Okay. We've been getting great feedback. As you know, once you ride it, you fall in love with it. And right now, the Future Shock is not transferable to other bikes because the fork and head tube is designed around the Future Shock.
Cool. There's a question. Someone says, one-piece bars, question mark, special stems needed, question mark.
No special stems needed. The Future Shock has a shim if you need to run a different stem.
So just to clarify, it's a standard inch and eighth, so any normal stem that you would clamp on any of the modern bikes out there right now would work perfectly fine on it. And so that leads to the bar also being compatible with basically anything on the market today.
Yeah, and I think the one-piece bar, maybe he's asking about the hover bar. Can you speak to that again?
The hover bar is not a one-piece bar. It actually works on any 31.8 stem. So you'll be able to use that. The hover bar comes in both carbon and alloy. It has a 15 mil rise, and it's our short, shallow reach and drop.
Cool. There's a bunch of questions on here about people asking about other bikes. Will this technology be on adventure bikes? Will we see this on other road bikes? Will we see this on Cruxes? People what do you think about that?
Well, we'll have to test it here in-house and see if the application is right.
Here's another question specifically about testing. How does the stiffness of the frame compare to the stiffness on that of a tarmac?
So this frame is actually pretty interesting. I would say it's probably one of our more advanced or most advanced composite frames that we've made to date. And so what that means is it has the same rider first engineering targets, so you get the same ride feel as you would expect out of a tarmac in that kind of crisp handling situation. The other really cool thing about it, and I know it kind of is a slight tangent to the question, is it's one of our lightest frames, or is the lightest road frame that we've produced. And so the composite technology that has gone into it in many ways actually exceeds what anything else is we have in the line today.
We have a question with the gentleman with the short shorts.
Oh. You come up here to ask a question?
Two questions, actually. First one is Future Shock. We have a FSR Future Shock rear, so mountain bike style of stuff. Can you do sweet jumps? Is this a shock style of thing? And second question, John, how many push-ups can you do in 1 minute? I'd love to see it.
I'll let you answer the first one.
So the serious question. The way to think about it, and kind of rolling all the way back to the beginning of the slide where we're saying we're suspending the rider and not the bike, the platform that you're on is still a road race bike. So anything that you would and wouldn't do on a road race platform still largely applies, except for the fact that your experience is that much smoother. And so we're not suspending the wheels. If you go ramming into a log, it will still impact the frame relatively hard.
Yeah. Second question, I guess, more than you, Sam.
We have Paul asking, we've had lots of riders asking about which is the correct spring for their weight. What do you guys recommend, and do you have a spring weight chart for people to use?
That is a great question. So let me jump on the weight thing, because that kind of leads into a lot of the research that we were doing in field testing. And I was the same way. Kind of the first assumption that you make is that it's got to be weight dependent, right? The tuning has to be a weight guide. And what we found was that most people, pretty much every rider in a road position, largely puts a very small amount of weight on the bars. It's something like 10 to 15%. And so even across a large weight range of riders, you're not really changing the load on the front end that much. And so we found that the more sensitive thing in your experience on the front end and tuning that spring is really the road condition. Because what's happening in the Future Shock isn't that you're moving up and down over the bike. It's more that you're holding the bars relatively steady in space, and the front wheel is responding to bumps underneath. And so that results in the spring being defined by what kind of bumps are coming in underneath, which is why John was talking about that chart. And it's really largely based on what you want to feel and what the road you're riding over is.
Correct. Yeah.
Thanks, guys. More questions coming in from online. How do we fine-tune rider fit without spacers? Any adjustment besides hover bar or flat bars?
So rider fit, there are some spacers that come with it. The max stack is 30 millimeters, so you can go up 30 millimeters from its lowest position. The other way would be changing the handlebars if you want to go lower, or yeah, that's about it.
So yeah, just to clarify, the bar is there to expand the fit range. There are still spacers. There just aren't as many spacers as would normally come with a traditional carbon steer. So to make up that difference, the hover bar is an option on top of that.
Awesome. So still a huge range of adjustments. Awesome. Okay, I think we got a question from a triathlete. How do aero bars interact with the Future Shock with additional weight forward over the spring?
Yeah, so that's a great question, and we've actually done a bit of testing there too, and that's when we start getting into the limit of my earlier statement where it's not necessarily weight dependent. There are extreme cases, so you can imagine if you're all the way just pogoing over the front end that it would be somewhat weight dependent. And so depending on your triathlon position, if it's fully forward and you're over the aero bars, that might be a situation where even with your road and normal preference on the hoods and drops that you would want to potentially go up a spring rate in the aero bars.
Is there any potential for the Future Shock to be tunable on the fly, like while you're riding a bike, like for different conditions for the road?
That's a great question, and it's something that we looked into early. And one of the things is we found that even among the three springs, the difference is relatively large. And so when it comes time to doing fine-tune adjustment, we didn't really see a large impactful performance benefit out of doing that. And furthermore, by introducing that kind of mechanism, it adds complexity And so going back to the service interval that John was talking about, that could be impacted, and also weight. It's still a road race platform, and so we're really trying to optimize simplicity and weight versus performance. Thanks.
Thank you.
Thank you. I think we have one more question, and it came in.
Cool.
It's about this statement right here. It's a very bold statement, and someone asked, well, how does this apply to the tarmac? Where does it leave the tarmac?
Yeah, so, I mean, there's horses for courses, right? And so what we found in our testing, especially with the pro teams, and I'll take it to the extreme because it's easier to understand in kind of like the really extreme cases, is if you go take a course like PM Roubaix and you ride a fully rigid bike over it, it's measurably slower. It's not even something that you need McLaren to tell you, right? You can just look on your Garmin or even feel it. You're way slower just because you're getting rattled and hit back. And in those cases, a system like the Future Shock can improve compliance. It's not just smoother, but it is significantly faster as well. And so you can extrapolate that to a lot of different conditions that we all ride in, whether it's potholes or broken roads. And so, again, it really depends. If you're carving nice smooth corners on perfect tarmac, right? But there's definitely cases where the Roubaix is a legitimate performance advantage.
Awesome. Thanks for taking that one. At this point, unless anybody else here in the audience has any more questions. Oh, I'm sorry. We have people waiting. Come on up here, please.
So my question is about the lack of zerts. I completely understand with the improvement in the front end why you wouldn't put zerts on the fork, but I guess my question is why remove the zerts from the seat stays?
We're able to, that's a great question, by the way, thank you. Kind of part of what I was talking about earlier with...
Can you maybe explain what zerts are just for a quick...
Yeah, actually, that's a great point. So on our prior bikes, all the way up to the SL4, we had these elastomer inserts that were called zerts that were inserted into the frame at different engineered locations in order to introduce more compliance, take off the buzz of hits. And they're missing from this bike. And so I'll kind of hit the front end, even though I think your question was more on the rear end. On the front end, as John was showing earlier with the Future Shock, there's no seals, no fluids, and so that was designed so that it would pick up a lot of the really small, high-frequency buzz that those zerts worked pretty great on. And so by designing that, we're able to cover the entire range and not need the zerts in the front end. In the rear, it goes back to kind of the advancements in composite engineering that we're putting into the frame. So between the drop clamp and the increased compliance of the seat post and the CGR, so there technically is an elastomer in the CGR, combined with additional compliance that we can actually engineer into the frame now without the additional compromise in handling, that all leads to a system that exceeds the compliance of prior zerts systems.
Hi guys, my name is Bill, and anyway, I have one question. As far as selling the bike, I have one of the questions I think my customers are going to come to me with is a moving part on the handlebar. How is that going to not have a play situation? I mean, most of our seat posts, the collapsible seat posts, all of them have just a little bit of give. How do I assure my customer when they come in and they don't have all that knowledge that this bike is not going to have that problem?
Great question, Bill. So we actually, this Future Shock is held to very high standards here at Specialized. Well, all our products are held to really high standards here at Specialized, but in particular this one, that was one of the concerns we had when we were developing this new technology. So we have a lot of high standards in our manufacturing. We also did really extensive field testing and lab testing. So I can tell a little bit about some of the testing that we did. This has been the most tested product in our lab. We had to stop the test machine because we were afraid of breaking our fixtures. Then for field testing, we actually rode this pretty much to the ground to make sure that there was nothing that was going to fall apart. We actually, for a whole month, rode this for over 10 hours a day. Some of us that live over the hill would ride over the hill in the morning, then somebody else here in the office would be ready to go take it out for another 2.5 hours, ride it, come back, then another person would be ready, take it out for another 2.5 hours, take it, and then the person that rode over the hill would ride back to Santa Cruz. And we did this with 5 field test bikes for a whole month. We did that 7 days a week. So we made sure that there was no issues at all with that. That was part of the testing.
And Bill, just to throw in another tidbit, I thought this was pretty cool, and this comes from one of our engineers, Chris DeLuzio. I learned that the Future Shock combined with the Roubaix and Ruby steer, that steer system together is actually our most stiff steer system across the entire line. And so that doesn't happen unless the tolerances are extremely tight and they're built solidly together. And so that's kind of a cool tidbit that you can use as well. Yeah.
Thank you.
Cool. Thank you. With that, thank you guys for joining us tonight. I appreciate it. All of you guys here, there, everywhere around the world. Have a great night. Bye. Thank you.
Thank you.
Thanks, guys.